Conics, Chapter 10, Section 1. So you may see the word conics and kind of look at it and go, what is that? Because it's probably something you haven't really heard before in your previous courses. So let's first take a look at what is a conic. So conics come from what's called a right circular cone. Okay, as you can see here, we have what look like two cones point to point. They have an axis down the middle, right? That's the axis of symmetry. They have the vertex, which is the point where the two cones touch. They have the generators. Those are these angled lines that if you set it at a certain angle and then rotate it around the axis of symmetry, it creates the naps or the sides of these cones. And that's what builds the cones. And you can say that that generator goes on forever in both directions. And therefore you have these infinite cones and they're point to point. So important terms you need to remember are axis of symmetry and the vertex. Naps not as important, and generators just a term that we may refer to that from time to time, but it's the axis of symmetry and vertex that are really your critical terms from that. So this is where conics come from, right circular cone, conic, okay? That's where it comes from. But what are the conics? And now the conics, you should be familiar with them. At least three of them, possibly four of them, you should be familiar with. Your conics are a circle, which is when you take a plane, a two-dimensional plane, and you slice it through one of the cones, part of your right circular cones there, and you do that perpendicular to the axis of symmetry, and that creates a circle. An ellipse, very similar to that, but it's slanted. So you take a plane, you slice it through the cone, but it's at an angle that is not perpendicular to the axis of symmetry, but less of an angle than the generator, so that it slices through only one of the cones. You've got the parabola, which we take a plane and slice it through a cone, and it is at the same angle as the generator, therefore only slices through one cone, but it never closes up again because it never makes it through to the other side of the cone. And we have the hyperbola, which is kind of like a double parabola, but it's done with a plane cutting through the cones where the plane is parallel to the axis of symmetry. And by doing that, it creates two shapes that look kind of like parabola, but it never cuts through the opposite side of the cone. Now, you could say there's an additional thing that we use that's not a conic section. If you were to take a plane and cut it through the vertex, where it is perpendicular to the axis of symmetry, that would give you a point, which you can see is very similar to the circle. And when you deal with the formula for circles, you'll see that if the radius of the circle is 0, you end up with a point. So there is a solid relationship between that. And that's an introduction to conic sections. They're used for a lot of different things. Obviously, you've seen circles all over the place, right? Well, the ellipse, the parabola, and the hyperbola, those are used for different reasons also, mainly just to give you a basic idea. With the ellipse, if you've ever heard of quiet chambers or silent rooms where someone can be sitting in one spot in a room and somebody else sitting in another spot in the room, and they can whisper and be heard in the other spot. That's due to elliptical ceilings and elliptical shapes in the room, which puts those two people in the perfect spot that they can communicate together, because every direction that the sound goes from the first person and bounces off something to get to the second person, it covers the same distance. So it all is in sync and therefore combines together to make it very easy to hear. Parabola, any sort of a satellite dish. So dish TV, olden days we actually had satellite dishes, or anytime you see these satellite dishes, or even with a flashlight or a headlight, the reflector for that is parabolic in shape, because it'll, if you get the light source in the correct point or the receiver for a satellite dish in the correct point, then all signals that go from that light bulb and hit against the reflector will go out parallel to one another. And then a hyperbola, similar uses, but not quite as common in daily stuff that you would see. So that gives us an introduction to conic sections.